Okay, good afternoon. Today we are continuing to work with those numbers. We are doing PO4. Remember, if it's a PO, it means it's a power objective. We've been doing COs, which are just course objectives. You just need to pass 80% of the course objectives of the year to move on. We have to pass 100% of the power objectives. It's an important one. So we want to make sure we understand this. We know how to do this because on the test, if you don't pass this one, you have to retake it. So this is one of those ones that we have to pass. PO4 is I can find the greatest common factor of a set of numbers. So those greatest common factors come up all the time. So we really need to understand common factors. So in order to know how to do this, we need to be able to know our definitions. So what is a factor? A factor is a number that goes evenly into the given number. So there's no remainders, no leftovers. It goes in evenly. So an example would be factors of 12. So think about that number 12. What are our factors of 12? Well, think of our factor buddies. We could have 1 and 12 because 1 times 12 is 12. What would be another set of factor buddies? Evelyn? 6 and 2. 6 times 2 equals 12. They go into it evenly. 12 divided by 6 is 2. 12 divided by 2 is 6. What is another set of factor buddies? Emily? 3 and 4. So those are all of the factors of 12. 1, 2, 3, 4, 6, and 12. Okay? I always like to find my factor buddies and then I put them in order. Because you're going to see that we want to find greatest common factors that numbers share. So it's good to find those factor buddies, but then you want to put them in order so you can see which ones are the biggest. Sometimes we need to actually write them out. Sometimes we can just see it because there's not a lot of numbers and we can just automatically see which ones are the greatest. So there are different ways to find greatest common factor. The first method 1 is listing them. Finding that instead of saying greatest common factor all the time, I like to call it the GCF, greatest common factor. So finding the GCF is as easy as 1, 2, 3, or FCG. Mr. Schultz is silly. All right, so F would be list all factor pairs. I'm going to give it a capital F so we know that's our F is the factors. List all factor pairs of each given number. So the first thing you do, the F, is finding all the factors. C would be you're going to circle the common factors. So if you want to find the greatest common factor between two different numbers, you list all the factors of one number, you list all the factors of the other number, then you circle all the factors that they have in common. Then our last one is identify the greatest common factor. So if you're going to do the listing method, you're going to list all the factors for each number you're given. You're going to circle the numbers that they both have in common, and then you're going to find the greatest one out of all the circled numbers. Method number 2 is prime factorization. Did you guys do prime factorization in 5th grade? I'm thinking that if I remember from last year, this one was kind of a new way of finding those greatest common factors. So you really need to pay attention to this one. So method 2, prime factorization. 1, you're going to use a factor tree.
We don't have lines. We don't have lines.
Okay, so it says, okay, yours is a little bit different than mine. Method 2 says the table method shown below. So what you're going to do is you're going to put a 1 and a 2 in that little space, and you're going to write just in the little space, and then what we have below, I have and you have the same numbers. So you're just going to write this in that little space. So use a factor tree to find the prime numbers, or sorry, prime factors of each number. And number 2 is you're going to find the product of the common prime factors. So we talked about in our math packet what our prime numbers are, going down as small as you can go, so you can't, simplifying it down as small as you can. Then if we're finding the product, what operation are we doing if we're finding a product? Evan? Multiplying. So we're going to find the common factors, prime factors, and then we're going to multiply. And I'm going to show you how that works. Reading the definition, it gets a little bit wonky, gets a little overwhelming. So we're going to, do we need more Kleenexes, Aiden? In the pineapple cupboard? Yep, right there. So it gets a little overwhelming when we're reading this and we don't understand what the words mean. But once I show you what it means, it's going to make more sense. So I'm going to, if we're good for me to erase, I'm going to erase this so I can scroll up so we can be up top showing off how to do our factor trees. Okay, find the greatest common factor of each set of numbers. Use both methods. So first I'm going to show you how to use the listing. So if I have 40 and 72, I want to list the factor buddies. What are my factor buddies for 40? James, give me one.
4 and 10.
4 and 10. What's another one? Emily?
8 and 5.
8 and 5. What's another one? Evelyn?
2 and 20.
2 and 20. What's another one? Do you have one, Evelyn? The easiest factor buddy that there is. Audrey?
1 and 40.
1 and 40. 1 times whatever the number is always going to be a factor buddy. I think that's it. Now let's look at our factor buddies for 72. Tegan? 8 and 9. Evan?
36 times 2.
36 and 2. Emmett?
1 and 72.
1 and 72. Oh, we've got more. Evelyn? James?
12 and 6.
12 and 6. James?
18 and 4.
18 and 4. One more. And you know what, James?
No.
So we found 1. 1 goes into it. 1 and 72. 2 times 36. Aiden?
24 and 3.
24 and 3. So when I'm searching for all of those factor buddies, I start with 1, I go to 2, 3, 4, 5, 6, 7, until I get up to where I'm repeating again. So if I did 1, 2, 3, 4, 5 doesn't go into it, 6, 7 doesn't go into it, 8, 9, and now I start repeating again, because once I get to 9, then it's times 8. So now I'm going back down. Audrey? Yes, you are allowed to use the calculator. Okay. So, who remembers what the second step is? I've listed my factors. So list factors, that's the F. Then we have the C. What is the C, Emmett? Circle the common factors. So they both have a 1. They both have a 2. Oh, there's no 3. But they both have a 4. No 5. No 6. No 7s. They both have an 8. 10, 20, 40. Yep, that's it. So I circle the common factors. Now G is identify the greatest common factor. So if I look at my circled number, what's the biggest number that's circled, Priya? 8. 8. So my greatest common factor is 8. So now I'm going to show you what making that factor tree was about with the prime factorization. So this time, I'm going to put my 40, my 72, and I'm going to make a little tree off my 40. What are 2 factors of 40? We don't want to do 1 and 40 because we already have 40 up there. 2 and 20. I like to go to the 2 if I can, because that's just easy for my brain. I always go to the 2 if I can. So 2 times 20 is 40. 2 is a prime. I can't break it down anymore, so it stays as just a 2. What can I break 20 down into? Tatum? 2 and 10. I can still break down my 10 more, so my 2's are going to stay the same, and I'm going to break down my 10 into 2 and 5. Can't break them down any more than that. Okay, 5 is a prime, 2's are prime. So I'm down to my lowest primes. So now I'm going to go over to 72. And I'm going to move it over just a little bit so I have a little more room. What can I break my 72 down into? What factors? Priya? 8 and 9. Are either of those prime?
No.
No, I can break them down farther. What can I break my 8 down into? Evan?
4 and 3.
4 and 2. What can I break my 9 down into? 3 and 3. Okay, so 2 is a prime. I can break my 4 down more, right? 4 can be 2 and 2. 3's are prime. So now what I'm going to do is it says find the product of the common prime factors. So I need to look at my list of common primes. So I have a 2 and a 2. I have a 2 and a 2. I have a 2 and a 2. No common for the 5 or the 3's. So what I have in common is 2 times 2 times 2, because there are 3 2's under both of them. So I need to find the product. I need to multiply those primes together. 2 times 2 is 4. 4 times 2 is 8. Look at that. Same common factor. James.
We did do this in.
Yeah, did you?
Yeah.
Okay. It's coming back now as I work us through it. Okay, good. So it's a good reminder because you probably didn't spend a lot of time on the prime factor tree.
No.
So it's a good reminder for us how to do that. So to find that greatest common factor, you can do it by listing them all and finding the biggest number they share, or by doing our factor trees. So let's see how we do that with 3 numbers.
I have a question.
Yes.
What if Priya said, instead of saying 8 and 9, she said 32 and
Oh.
36 and 2?
Good question. What if we started off with a different set of factor buddies? So if we had 72 and we did 36 and 2. 2 is a prime, so that's going to stay a 2. What can I break 36 into? 18 and 2. 2 is a prime, primes stay the same. I can break down 18 into 2 and 9. 2's stay the same. I can break our 9 down into 3 and 3. Look at that. 2, 2, 2, 2, 2, 2, 3, 3, 3, 3. Any set of factor buddies for a number will get you the same primes. So it doesn't matter which factor buddy you start with, you will always end up with the same set of primes for that factor. Evelyn. Yes, you can use a calculator to help you find your factors. Okay, but the calculator is not going to tell you which factors the 2 different numbers share in common or the 3 numbers share in common. But you can use a calculator to help with that. We're not doing that right now as we're working. So this came up in my other class. Some people are saying, ooh, I get it. I'm going to just do my assignment now, and I'm not going to listen to what Mrs. Gambino is doing for her lessons. I'm going to work ahead because I want to make sure to get it done. The problem with that is sometimes I talk about stuff that you don't realize you don't know. You're doing it wrong and you're working ahead and getting your work done, but you're not doing it correctly. Therefore, you're not learning it. So I ask that we have patience, and if we're understanding it, just keep following along with me. Don't try to work ahead, because that's when mistakes happen. That's when we don't fully understand something, and that's when we get stuff wrong on the test. Okay? So really don't work ahead on it. Let's look at what we do when we have 3 numbers. I'm just giving myself some more work room so I can make it nice and big for you guys to see. So now I have 12, 30, and 60. Let's do our listing method first. Let's list what the factors are for 12. Tegan? 6 and 2. Evan?
4 and 3.
4 and 3. Tatum? 12 and 1. I think that's it, right? So let's list our factors for 30. Aiden?
6 and 5.
6 and 5. James?
30 and 1.
30 and 1. Michael?
10 and 3.
10 and 3. Ben?
15 and 2.
15 and 2. I think that's it. Right? Yep. So let's look at for 60. What are my factors? Tegan? 6 and 10. Emmett?
15 and 4.
15 and 4. Emmeline?
15 and 1.
60 and 1. Evan,
12 and 5.
12 and 5. Ben,
30 and 2.
30 and 2. If there's one more.
Okay.
James,
30 and 2.
we've got 30 and 2. Tegan,
20 and 3.
20 and 3. So I listed them. I listed the factors. Now we're at the seed. What do I have to do for my seed? Evan?
Circle the common factors.
Circle the ones that all three have in common. So I know they all have a 1 in common. Do they all have a 2 in common? Yep, I see a 2 under each of them. Do they all have a 3? Yep. Do they all have a 4? No, 30 doesn't have a 4. Do they all have a 5? 12 doesn't have a 5. Do they all have a 6? I see a 6 here, here, and here. No 7s, no 8s, no 9s. 10. Oh, 12 doesn't have a 10. 11. No. 12 and 12, but no 12 here. That's the biggest number that 12 has. So I know there can't be any of these other big numbers because they're not going to be under 12. So I circled all my common ones. What's my last step, Priya?
Find the biggest factor.
Find the greatest factor, which is 6. All right, so now let's try doing the factor tree with all three numbers. So if you're running out of room on your page, because I'm running out of room on here, you can use that page to your left, the backside of yesterday's or Friday's. So if you need to do the factor tree, if you're going to run out of room, you can do the factor tree to the left where you have space. Yes. So are we good if I erase our factor buddies? So I have room up here.
I like how you call them factor buddies.
What?
I like how you call them factor buddies.
Because that's how I learned them, and I used to teach younger kids, and so I always use that term when I taught kindergarten and first grade. I used factor buddies, and it just stuck. They're fun. You always have to know to find its buddy. You're not just going to put 2 as a factor. You know it's going to be 2 and 6 for the 12. All right, so let's do our factor trees. Let's start with 12 first. 6 and 2. 2 is a prime, so that's just going to stay 2. What can I break the 6 into? 2 and 3. 3 is a prime. So that was a quick and easy one. James?
The next one is 10 and 3.
Okay. So 3 and 10. 3 is a prime, so it's going to stay a 3. What can I break the 10 into? A 2 and a 5. They're all primes. I can't go down any smaller. Whew, that was an easy one too. All right, let's do 60. What factor buddy set should I use? What was that? 10 and 6. All right, neither one of those are prime. So I need to break them both down into lower. What's factors of 6? 2 and 3. What are factors of 10? 2 and 5. Those are all prime numbers. I can't go any smaller. Aiden?
Do I have to use the same factor buddies you're using as before?
So when we're working it through in class, I'm going to ask that you use the same factor buddies so it makes sense. So what I circle, you're circling, and we get the same answers. If you do one that's different, I guess it's okay if you do one that's different as long as you end up with the same primes at the end.
Yeah, I did 30 and 2.
Yeah, so if you did 30 and 2, and then you broke the 30 down into 15 and 2, and then you broke 15 into 3 and 5, you should end up with the same prime. So I'm going to change that. Sorry, I know you were busy erasing. But if you did different factor buddy, make sure that the primes you end up with in the end look the same as my primes. Because remember, it doesn't matter which factor buddies we start with, we end with the same primes at the end. So now that I did my trees here, what do I do? Tatum? Audrey. I'm going to multiply them all out. 2 times 2 times 3 times 3 times 2 times 5 times 2 times 3 times 2 times 5. That's a lot of multiplying. We're not going to make ourselves do that much work. You're right about the multiplying, but there's a step in between. What step is in between, Aiden?
We have to find the greatest.
Not the greatest. Hugo.
All the common.
We have to find the common factors between all the numbers. So, I see there's a 2 here. That matches with that 2 and with that 2. Okay, there's a 2 here. Oh, there's not another 2 here. So I can't circle that 2 because there's not another 2.
You only circle 1, 2? Yes.
You can only circle 1, 2 in each group.
Because one of them only has one.
Right, because the 30 only has 1, 2 listed. So I can only circle 1, 2 under each of them. Is there a 3 under each?
Yeah.
Yes.
No,
So now when I do my multiplying, because we're out of factors now to primes to be looking at common. Now when I do my multiplying, I multiply 1, 2 times 1, 3. And that's it. Because that's the numbers that they share in common. They share 2 and they share 3. So 2 times 3 is 6. That is the same greatest common factor that we got when we did our listing. We had a 6 was that greatest common factor, and we have a 6 here. So we get the same answer. So numbers are relatively prime. Sounds pretty cool if you say it in a British accent. I am not good with accents. Mr. Gambino is super good with accents, and so I get intimidated by him because he loves doing accents. I'm just not that good. I can do an Italian accent sometimes, but so Gianna likes to say Tuesday, so for Tuesday, but that's not relatively prime. Anyways, numbers are relatively prime if their only common factor is a 1. If the only factor that you can circle is a 1. They are not prime numbers themselves, but are prime when compared to each other. So 8 and 15 would be an example. So for the 8 and the 15, let's see what that looks like. When we list out our factor buddies, we can see that the only number that they share in common is their 1. So they are relatively prime because the only factor they share is a 1. So 8 is not a prime, 15 is not a prime. We can break them down. But the only factor they share is a 1, so they are called relatively prime. If we were to do it with our factor trees, and then we break down that, we can see that they don't share any prime number. So when you do your factor tree, if they share no prime numbers, they are relatively prime because they all share a 1. If you do factor buddies and the only number you can circle is the 1, it is relatively prime. So that means the only factor they share is a 1. Make sense?
Yep.
Okay. So our second page,
Oh, that's what.
this is your work page. Find the GCF of the set of numbers. You may use either method you wish. It's possible that the numbers will be relatively prime. For whichever method you do, if you do the listing or if you do the factorization trees, you have to show your work. You can't just say in your head, okay, I did the math in my head and I'm just going to write down the answer. I do not want to see just an answer. I want to see you doing the work. Right here where we have the space, do your work where there's space to do it. Circle your answer, because you're going to have a lot of numbers. Circle the answer of what the greatest common prime is. And is that the whole page? That's the whole page? Oh my goodness.
Yeah.
There is a third page.
Third.
So, don't just stop at doing the greatest common factor page. Turn to the next page and there are word problems. Your grade has 48 students. List all the possible ways you could divide your grade into equally sized groups using all the students. Hint, factor buddies. Factor buddies. Think about how many groups and how many go into those groups. So if you have a group of 3, you could have 16 in the group. Flip it around. You could also have a group of 16 with only 3 in a group. So make sure you write it going both ways. A group of 16 with 16 groups with only 3 people, or 3 groups with 16 people in each group. So you have to say it both ways for all the factor buddies. When you get down to these bottom ones, you're going to be using factor buddies. Okay, looking for this one, yeah.
It's all factor buddies.
Yeah, it's all factor buddies. James.
Can I say G and P for group and people?
Yeah. Yep. You could say 3 G's of 16 P's. Emmeline. Are they really? He didn't keep them the same? Okay, so if your word problems are different, I will make sure that I get the page that you guys have. This was last year. He told me he didn't change the binder from last year, but he did.
Mine's the same. Yeah, mine's different.
Okay, so you're going to do the one that you have, and I will come up with the answers for both sets. Okay? I already have the answers if yours are the same as on here, but if they're different, I will come up with those also. If you are at home watching this, just know that what you're seeing on the screen may be different word problems than what is in your binder. So make sure that you do the ones that you have in your binder, and I will come up with the answers for that. So we hope you are well, and we hope to see you soon. Have a good day.